All right. So being new in this, we are also seeing a lot of growth. Singapore or Asia Pacific is probably the youngest across all of the three consortium. So unlike Fraunhofer and Zurich here, we have only been incorporated into the organization about 5 years ago. So that really makes us the youngest across the three organizations. And but we really see a lot of growth, and we have seen the Asia Pacific market really picking up the momentum of leveraging and adopting ROS. So we started in 2017 with about 4 people and 4 organizations. Today we have grown quite strongly into 20 over engineers developing, establishing, deploying ROS capabilities for the Asia Pacific region. So today what I'm going to talk a little bit about is what we do in Asia Pacific, some of the new program development, and how we help and support proliferating the adoptions of open source ROS for the Asia Pacific market. But before I do that, just giving a short introductions about ROS-Industrial and the organization that we belong to. So ROS-Industrial is actually under ASTAR, which is a national research institute under the Ministry of Trade and Industry. So we are part of the public organization and government agencies that allow us to help in really supporting the community in developing science and innovative technology that really help and support the economic growth and improving lives across the nation. As an A-star, we're probably about 1/5 the size of Fraunhofer here, but we've grown quite a bit. We have about 6,000 over staff across the board, 4,500 research and engineers. And we have a lot of participants internationally coming over from all over the place to help in building the research community. There are about 20 over research institute under A-star. The one that we are being managed on is under what we call the Advanced Remanufacturing and Technology Center, or short for ARTC. If you see, there are like 2 different colors there, the blue and the green. The blue is the one focusing on the science and engineering, and the green color focusing on the biomedical research capabilities. So this is just a very, very quick snapshot of what ASAR has achieved based on the RIE 2020. So our research grants typically runs every 5 years. Now we're running the second tranche of the 2025. But this is basically what we have captured last time in 2020, where overall we had about 6,000 projects really undertaken, developed as an industry, and translated into the companies working together and deploying some of those innovative solutions to help in elevating the overall capabilities within the region. And I'm going to talk a little bit as well about the institute that ROS-Industrial is being hosted on, and how naturally we really help and support some of the technology development and putting the capabilities with that. So the Advanced Remanufacturing and Technology Center focusing a lot on the translation capabilities from and really bridging where the research is into the industry. So the focus of that, and we always call ourselves as a leading public-private partnership. What that really means is that we wanted to sort of bridge where we can leverage on the technologies and really building that ecosystem of innovation partner in helping to proliferate adoptions of the technology and catalyze this co-innovation and co-development across the different industry pillars that we are focusing on. As an organization with the Advanced Manufacturing Technology Center, we are operating as a consortium as well. So they have about 96 offer members within that. We have about 300 course staffs, more than 55 PhD students. Again, comes from all over the place. We have a lot of international participants as well. We work in a few different core technologies teams that you see there, from additive manufacturing solutions, autonomous system robotics, supply chain, IPVs, and so on. We also run a few industrial flagship program, in which ROS-Industrial Consortium is actually one of the programs that is being supported and managed within this organization. So with that in mind, I am going to also share about the strategic R&D teams that the organization is focusing on. They're basically four broad teams: the advanced manufacturing process, autonomous manufacturing, focusing on how we can intelligently develop a system that can optimize the imaging. And this is also where the robotic applications and development that we are developing is actually being focusing on. The other part is on the resilient value chain, and finally in supporting the sustainability towards achieving the net zero manufacturing. Now with that in mind, I am going to now move on to what ROS-Industrial Consortium Asia Pacific really do. So I mentioned earlier that across the three consortia, we are the youngest. We started with 4. Today, we have about 20 over members. We have also recently being joined by another institute of higher learning, Korean Poly, and we are also looking into our pipeline a few more companies that is very, very keen to get on board on this band. This is a very interesting development for us, and especially with the Asia Pacific. I think a lot of times when I just joined, a lot of people was like, oh, what is ROS? Why do I need to use ROS and all of that? But today, moving forward 5 years later, and we actually see people really coming and say, hey, can we really join the consortium? Can we help and support that? How we can get on board? And what do we need to know how we can apply it for ROS-Industrial application? We're actually especially seeing a lot of interest coming from the Japan region, for example. We see a very, very strong demand from there. So if you look into the logo that we've got there within the consortium, we have about 7 to 8 members really coming from Japan. So looking into that, we're probably looking into be able to support that further moving forward. With the new changes on the organization structure, and also looking into how we need to better support our members and what they're actually focusing on, recently we changed our organization structure to help us in focusing more into our capabilities. So there are basically 2 broad categories there that we are focusing on. One called intelligent robotic manipulation, where our focus development is really looking into supporting development in the perception and manipulation capabilities that the industry can hold and leverage. The second group is really looking into mobile robotics, and we term the group multi-robot autonomy, where we're actually developing capabilities leveraging on navigation and the interoperability across different mobile robots. And this is also something that is quite uniquely, we face in our region. We see a lot of development and interest coming from the mobile robots, and especially in the service industry, where a lot of the robots are actually being applied today within the Asia Pacific region. We see this as one of the core importance where the ROS need to move into. So I have here with me also my colleague from Singapore. I have Andy and Chantat. So Andy is the advisor and sponsor of ROS-Industrial, and Chantat is my technical group manager that basically manage the entire technical group here. So when we started this journey, 5 years ago, we did do a lot of, development, proliferation, marketing, outreaching, and really tried to gain a sensing of what the entire community sort of wanting to. And, I really did resonate with what Sean mentioned, right? It's like, oh, why do I need to use ROS? Is it really ready to be used for industrial applications? We did face that in the very beginning. So a lot of like my predecessor before, really focusing and supporting those outreaching and showcasing projects after projects. But 5 years into the road and looking into how we have then finally sort of gained some sort of momentum in showcasing the power of ROS and how we can really help and support the community, we thought it is also about time for us to really look into our strategy, how we can be a bit more focused, a bit more structured, in the way we are actually supporting the community. So this year we are, focusing how we wanted to do that, and there are three basically key focus areas that we want to focus on as the consortium. The first one is really in developing the capabilities. So recently we conducted our members road mapping session, in which across the entire members, one thing for sure that people really lack of talents, right? So yes, we are actually pretty young, we are actually very new, and a lot of interest really wanting to use and adopt ROS. But then when we actually turn back and look into who can really develop, who can really support if we're actually developing something, we do not see a lot of that, at least in the region. So we support that. We develop a new program. We call them the Train and Place program, when we develop a training and we support the internship and secondment and placement within our organization, so we can handhold the industry in really leveraging and adopting ROS. The second thing that we are looking into is really to seek into the standardization. So a lot of our members really look back and says that as ROS-Industrial, at least they wanted us to look into how we can help in supporting some, probably not standardization per se, but also in terms of best practices. How should we develop certain things better? For example, how we can, learn how you develop certain things. So when we develop it for our own commercial application, we have some assurance that things are actually being developed in certain standards and or in adherence to what the rest of the community in ROS is actually using on. And finally, and this is what I'm going to touch a little bit more, is really into being able to create some kind of like stable environment and capabilities and packages that the industry can easily adopt and build additional application on top of. So we are focusing a lot in developing a platform technologies. So our spectrum of implementation involvement, typically all the way up to the proof of concept and first level of piloting. But after that, the whole idea for us is really to then pass it on to the industry, so then they're able to accept that and bring additional value on top of that. So that with that in mind, I'm going to reintroduce what the key topic of what I want to talk about here, and how we are really categorizing our activities within the consortium. So there are basically three levels of research domain, I would say, that we are focusing on, from component level to subsystem and system-to-system kind of applications. So on the component level, we are looking into developing what we call a universal robot controller. So the whole idea here is that if, for example, we wanted to develop a bespoke, robot application, where you wanted to put in different kind of brands and models. So let's say you have a different models for your arms, a different model for your mobile robots, we wanted to see how we can enable that a lot easier. So I'll talk a little bit about that in my subsequent slides. So the whole idea is that to do an inverse kinematics that will be able to then translate it into the ROS packages. So then we are able to leverage on ROS advanced applications. So the second one is really to sort of help in developing a ROS Blue driver framework. So where we are saying, at least in our community, they're very little, or at least for where we are coming from, there's very little guidance of how we are supposed to be developing a ROS Blue driver framework. So this is currently an effort that we are actually working on together with one of our members to help building how the ROS Blue driver should be looking like, so then they're able to replicate a similar effort should they wanted to develop the ROS Blue driver for their application moving forward. So the second one is really on the subsystem. So this is where we are defining how we develop capabilities that pull in all of the different component levels application together. So we are focusing the first one on the automated workspace creation that allows an artifact free identifications with some kind of like self-corrections. And the second one is also on the whole body coordination. We're leveraging and looking into the mobile manipulators and looking into how we can balance performance and kinematics with the safety assurance. And finally, looking into the system-to-system capability. So this is really basically bringing all of these elements together and putting it sort of like across the entire spectrum, looking from design all the way to the operation. So looking into the simulation, looking into the platform capabilities, and looking into the system integration that really pull all of those things together. Okay. So this is the first one that I mentioned earlier, where we are looking to develop the packages that help in developing a ROS-I native universal robot controller. So this is actually part of a program funded by the Singapore government under what we call the ROS-I AP Program. It's a pre-positioning sort of funding that helps to support a platform technology, foundational technologies that the industry can then take up and leverage on. So the whole idea that we wanted to develop in this one is to develop a compact hardware and software system that will be able to provide a direct communication between robot actuator and the ROS-I framework to really utilize really high level, all the different ROS capabilities that is actually existing out there in the market. So where we are really focusing in terms of the research is to create a hardware level direct communication with the ROS core modules, developing an adaptive kinematic and inverse kinematic modeling for multi-axis configuration. So we are looking into a greater than 7 degree of freedom there. We're looking to look into the nonlinear interpolation for smooth robot trajectory and velocity profile. So here we also see we wanted to focus on how we can minimize the RMS error there. The thing that we will come up out of this thing is to come up with the open and sort of modular robot control system architecture for integration. So what really the whole idea and the problem statement that really will come from that is that if you wanted to put all of this in, so if you see here, this particular application that probably you couldn't find, off the shelf capabilities application, you want to develop something new, putting all of these things together typically will take some time. So the whole idea here that we wanted to support this universal robot controller to actually help to shorten that time of development and being able to put that into the market a lot quicker as well. So this is so the second one that we are developing is the ROS-I driver framework. So this one, we are developing this in collaboration with one of our members. So they're basically very new into the ecosystem. They have been around in the market, one of the global leader. But when they actually came to us, they have zero idea how to develop ROS-I drivers. So we took a lot of time to sort of educate and actually helping to share with them what sort of, how we were supposed to be building that. And the great thing, there's so many resources, of course, within the community that can actually help and support that. But where we wanted to then contribute back to the community is that once we develop this for these particular companies, we wanted to then share what are some of the learning points, how we're actually structuring the ROS-I driver that we're developing for them. And we are doing this, we're including the GPIO and the joint trajectory control for this development. So this one just started, we're just starting this particular project. So hopefully the result of that will be out by end of the year. And the whole idea there, once the ROS-I driver has been developed, we will be open sourcing it and sharing it with the community. So then the community can then test it out and see what are the improvements that can be put in for this driver as well. Moving on to the subsystem level of development. So we are looking into the technologies to do an auto configuration and self-tuning of a very complex digital workspaces. So there are two types that we're actually looking into. The first one is really looking into precision and creation of artifact-free post-estimation using a fusion-based 3D localization. They're actually able to compensate any self-correct and compensate any drifting that actually happens across the time. And the second one is to look into a very large object and a very large field of view, kind of like workspace where we can actually able to stitch all of the different sensors, be it a LiDAR and camera and camera, and being able to put all of this information and sort of generate a workspace that we can actually then utilize for multiple different applications. On the right side, on this one, this one is the development of a technology to support the safety assured autonomous mobile robotic automation. So here we are looking into a whole robot body coordination. So where we're envisioning where these capabilities will go into is that if you have like a moving robot and with the arms, they're actually able to do a task on the go. So without having to have the mobile robots to stop, they're actually able to do that on the go. But not only doing that from the kinematics perspective, we wanted to also embed safety as part of that. So let's say if the robot identified that there are potential obstacles that's coming in, we wanted to be able to identify that. So there's a lot of balancing in terms of the performance and the kinematics as well as the safety applications. So where we wanted to put this forward is really to put this in a high dense kind of like manufacturing environment, for example. And in fact, this particular technology right now is actually being prototyped and run as a proof of concept for one of the very large, so we have what we call a food court in our area. So in those spaces, it's very congested. There are a lot of people working there. We wanted to deploy and utilize this. So very, very dynamic environment with a lot of people and a lot of obstacles, a lot of very changing spaces. And that's where we see where this application can really flourish. Then I want to talk also on one of the results of the focused technical project. So this is the very, very first technical project. How long do I have more? 5 minutes?
Yeah.
About 5 minutes. Okay, I'll try to speed this up a little bit. So this is actually our very, very first focused technical project that we had just completed actually in December. So this development is being conducted in collaboration with our members, Johnson & Johnson, Infineon, as well as Delta. So where we wanted to develop is a technology demonstration for the robotic middleware framework, specifically for our logistic applications. So here, as you're probably already aware, the RMF was created previously for our healthcare sector. And in order for it to actually be adapted for other industry, there are several things that we feel that needs to be done and need to be researched on. So the first thing that we developed as part of this technology demonstration is actually to develop 2 main use cases. So the first one is in the order and replenishment type of use cases, and the second one is in the inspections. Where we're seeing one of the probably greatest difference between the healthcare applications and the logistic applications, or maybe manufacturing application. Manufacturing, or maybe if you wanted to utilize robot, for this one and really achieving those sort of autonomous operation and manufacturing, there has to be a way for the task to actually be triggered by some kind of like external conditions, right? So for the order and replenishment use cases here, we trigger the task scheduling and dispatching utilizing inventory tracking. So once the inventory actually goes down, we actually trigger the task dispatching that then send the command to RMF to say that, okay, you now need to send one of the robots within your fleet management to go and conduct the task. For the inspection, we are actually taking the input from the sensors. So the whole idea there is that if, for example, we put in a some leak detection, gas leak detection kind of like sensor on the robot, and let's say the robot's conducting some surveillance, and if they have detected certain anomalies, it will actually trigger another task dispatch within RMF to then send another robot to go and like do some kind of inspection in certain areas. So we develop an asset as well. So we develop the logistic flow within this FTP. The result of this will all be open source within the next 2 months. So I'm going to just share a very, very quick video of what we were actually developing for that. Oh, there's no sound? Okay, that's okay. We created the assets and the inventory there. Whereby all of the assets can then be reusable as all these in gazebo, so you can utilize this once we open source all of the assets. So we created the forklift and the workflow integration as well to actually help in adopting the robotic middleware framework for the logistic applications. So here we see the robot actually goes and pick up the order. So the order tracking was actually being shared through RMF. So we create that 2 new task definitions, if you may, to be able to conduct this one. So we have this simulation asset as well. So it is now fully integrated as well with the conveyor and over. So as part of these things, we also do some kind of like benchmarking on the type of task dispatching mechanism that we needed. So we have like a few different scenarios where we're doing this. So this is where the robot actually pick up the order and do the replenishment. So as part of the tasks here, we have the work in progress sort of mechanism. So the robot can actually go and pick up an order of certain locations. And if there is a very low inventory, we'll actually trigger another robot to go and replenish first before they actually complete the task. Am I out of time already?
Yeah, 2 more minutes.
Okay. Let me see how many minutes. Yeah, so then, so as you can see here, all of the different robots is actually working together in this logistics world. Okay, so I'm going to try to like just speed up this particular thing if I can. I can't. Okay. Yeah, so that's basically what probably a very quick snapshot of the result of our first focus technical project with our member. So we are developing the second phase of that, and we'll be really focusing on like sort of repackaging some of those integration that we talked about earlier. So these are all of the list of the new packages that we will be releasing very shortly coming out of this focus technical project. Notably the workflow integration, the new custom task manager, and a few different assets that we are developing as part of this logistic application for RMF. And just a very quick announcement of the next ROS-Industrial Asia Pacific workshop. It will be end of the year, so it will be a little bit further from now. So it will be in Singapore. So we welcome everybody here to come to Singapore to join us in our workshop as well. All right. So I think with that, that's the end of the presentation.
Thank you, Maria. Any questions for Maria? Do you have like a minute?
Yes.
Yeah,
Yes, yes. So the whole thing is really leveraging on ROS culture. In fact, after the framework, we wanted to use that. Yeah.